You are welcome to part 5 of this titration training, which is focused on preparing for titration. Our objectives are filling and Burette setting, Burette reading, and titration table. Under Burette setting and filling, let's look at the apparatus needed. Here we have the Burette and the rotor stand. So the rotor stand helps to hold the Burette. This is a clamp Burette on the rotor stand, as you can see in this picture. The details of Burette setting and filling will be covered later in this tutorial video. Let's quickly look at Burette reading. A 50 cm cube Burette is used, which is numbered from 0 to 50 cm cube. Reading of Burette must be in 2 decimal places. That must end with either 0 or 5. So as we have the Burette graduated from 0 to 50, being in 2 decimal places, we can now have 0.00 as the starting point. We now have 0.05, 0.010, 0.15, 0.20, 0.25, and so on in that order, where the value ends with either 0 or 5. Take note. Example of good reading, we have 20.05, 31.55, where the value ends with 5. We have 17.50 and 31.00, where the value ends with 0. So if your value does not end with 5 or 0, you have a very bad reading. Example of bad reading: 20.11, 31.56, 17.59, and 25.54, and so on. To read correctly from the Burette, you must take the reading from the bottom of the meniscus. This is the meniscus. The green line shows you the bottom of the meniscus. So the reading here is 19.50 cm cube. Titration table. Let's look at the features of this titration table. We have the Burette reading in the first column. We have rough as the second column, first titer as the third column, and second titer as the third column. Under the Burette reading, we have the final reading, initial reading, and volume of B used. This B is the solution that was added in the Burette. The solution that was in the Burette. If it's WAEC or NECO, they may say add solution E, add solution F, or put solution B, put solution F in the Burette. So that is depending on the question. This letter B might change. It might become A, depending on the question, depending on the solution you are putting inside the Burette. Based on what we are doing now in this our project, the sample we are taking is B. So that's why I'm writing here volume of B used. Because B is the one inside the burette, and this table has to do with value from the burette. So look at the arrangement. The final stays up, the initial stays down. Very, very important. This is your titration table. Titration table 2. The difference here, difference between the second table and the first table is that, look at it, the first table has rough and ends with the second titer, while this second table has no rough. So it has first titer, second titer, and third titer. Under the burette reading here, the features here are the same. The only difference is that the first one has rough and ends with second titer, while the second one has no rough and ends with third titer. So any one of your choice can become your table. Finding average titer value. Two or three concordant titer values must be used. From where? From this space here, where you have volume of B used for the first titer, volume of B used for second titer, and volume of B used for third titer. How do you get the volume of B used? Final reading minus initial reading. Final reading minus initial reading. Final reading minus initial reading. So you get the volume of B used for each of the titers. For each of the titer. At the end, you have three titer values representing volume of B used. From the three titer values, that is where you choose two or three concordant titer values. Concordant titer values are titer values that are very close to each other with a maximum difference of 0.20 cm cube. With a maximum difference of 0.20 cm cube. So the difference can be 0.10 cm cube, 0.15 cm cube, or 0.20 cm cube. The difference between the two numbers or three numbers representing your concordant titer values should not exceed 0.20 cm cube. But in WAEC, it is advised you make use of the difference of 0.15 cm cube, so that by mistake, even if it exceeds 0.15 cm cube, it will still land at 0.20, so that by mistake you will not exceed 0.20. So in this our work, we'll be making use of the difference of 0.15. Remember, the difference can be 0.10, 0.150, or maximum difference of 0.20 cm cube. So let's look at this question now. What are the concordant values of the 23.45? What are the concordant values of 23.45? Okay, how do you go about it? To find the concordant values of this 23.45, I have two options. Either to go to the increasing side, or I will go to the decreasing side. What do I mean by increasing side? The concordant values of this 23.45 should have a difference of 0.20. So it's either the values are higher than 23.45 by 0.2. No, now we are using 0.15, remember, by 0.15, or it is lower, or the concordant value is lower than 23.45 by 0.15. So being lower means you are going towards the decreasing side. Being higher means you are going towards the increasing side. Any side you want to go is your choice, provided it is within the limit. So the first option here now, looking at the increasing side, to go towards the increasing side, you do addition to find the highest value. So we add 0.15, which is the difference factor we are using, 0.15. So that gives us 23.60. So it means that highest value from 23.45 is what? 23.60. So therefore, concordant values of 23.45 are 23.45 itself, 23.50, the next value after 45 is 50. After 0.50 is now 0.55. After 0.55, you now have 23.60. You stop, because that is what the highest value says when you are going towards the increasing side. So by going towards the increasing side now, we have gotten 4 concordant values, which are 23.45, 23.50, 23.55, and 23.60, which is the highest value. If I choose to go towards the decreasing side, I have to subtract that 0.15, which is our difference factor. How do we get 0.15? From the meaning of concordant theta value, it says are theta values that are very close to each other with a maximum difference of 0.20. The difference can be 0.1, the difference can be 0.15, and the difference can be 0.20 as maximum. So we are choosing 0.15 to be our difference factor, to be in a safer side. So now going towards the decreasing side, we're minus 0.15. So when we minus 0.15, we now have 23.30, which will represent lowest value from 23.45 if you are counting down. So therefore, concordant values of 23.45 are 23.45 itself. You start counting downwards, decreasing. The next value following it will be 23.40, counting down. 23.35, counting down. 23.30, so you stop. So we have 4 values here: 23.45, 23.40, 23.35, and 23.30. That's our concordant values. So we have 4 concordant values here now. What we are looking for is 2 or 3. So you pick any 2 or 3 of your choice. Now, what you must know here is that if you are choosing increasing side, stay there. Choose your concordant value from increasing side. Not when you are facing or choosing increasing side, you pick 1 from increasing side and you go and pick 1 again from decreasing side. You will land yourself into trouble. If you are choosing your 2 or 3 concordant theta values from increasing side, stay there and pick it. You have enough values, about 4 to pick. Don't pick one or two and come down to the other side and pick another one. Stay wherever you are. If you are staying at increasing side, stay there. If you are staying at decreasing side, stay there. Don't pick from here and pick from there. Average value of BUs. How to calculate it? So from the concordant values you have selected, maybe you selected 3 concordant values. You now have first theta plus second theta plus third theta divided by what? 3. If you are picking 2 theta values, you pick any 2 of your choice. First theta plus third theta over 2. Any 2 of your choice. Divided by 2. Answer must be in 2 decimal places with units. Answer must be in 2 decimal places with units.